Welcome back to DM Academy. Okay, let's have this average velocity and instantaneous velocity problem. A particle moves on xy plane with a position vector of r of t is equal to 2.40 meter per second cube t cube I hat plus 3.10 meter per second square t square j hat. Okay, we will determine the position of the particle when t is equal to 2 seconds. And what is the average velocity of the particle from t is equal to 1 second to t is equal to 3 seconds? And lastly, what is the instantaneous velocity when t is equal to 4 seconds? Okay, so let us solve. Okay, for letter A, we will determine the position of the particle when t is equal to 2 seconds. Given this equation, r of t is equal to 2.40 meter per second cube t cube I hat plus 3.10 meter per second square t square j hat. We will just evaluate this function by substituting t be equal to 2 seconds. So again, we have r of t is equal to 2.40 meter per second cube t cube I hat plus 3.10 meter per second square t square j hat. So again, we will just evaluate this by substituting t be equal to 2. So that is r of 2 seconds. So we have 2.40 meter per second cube 2 second cube I hat plus 3.10 meter per second square 2 second square j hat. Okay, then let us simplify. We have 2.40 meter per second cube. 2 second cube is 8 seconds cube. I'm sorry, that is 8 second cube. I hat plus 3.10 meter per second square. 2 second square is 4 second square j hat. Okay. Then the position of a vector, the position of the particle when t is 2 seconds is equal to 2.40 multiplied by 8, that is 19.2. We have 19.2 meters as we cancel out the unit second cube. And that is I hat plus 3.10 multiplied by 4, that is 12.4 meters along j hat. Okay, so this is the position of the particle when t is 2 seconds. Okay, then for the next problem, what is the average velocity of the particle from t is equal to 1 seconds to t is equal to 3 seconds? Okay, so to compute the average velocity, we have the average velocity is equal to, since the particle moves along x and y, we have the change in position along x divided by the delta t, that is I hat, plus the change in position along y divided by delta t k hat, along j hat, sorry. And that is also equal to the position, the delta rx, the delta r along x would be the final position along x minus the initial position along x divided by the delta t, wherein delta t is final time minus initial time. Then plus the delta r sub y is the change in position from the final position along y minus the final position, or rather the initial position along y divided by the final time minus initial time, j hat. Okay, forgot the I hat here. Okay, so as you can see, we need to solve first the final position along x and y, even the initial position along x and y. So the r1, or the position vector, when t is equal to 1, will determine the initial position, and the time be equal to 3 will determine the final position. So we will solve first the r1 and r3. Okay, so we're in the r1, r of 1 is equal to, so using this equation again, 2.40 Okay, so using that equation again, we will evaluate the r1, or r of 1 second. Okay, that is 2.40 meter per second cube, 1 second cube, I hat, plus 3.10 meters per second square, 1 second square, j hat. Okay, so to evaluate this is at 1 second. This is 2.40 meters I hat plus 3.10 meters j hat, because as we're going to cancel out the unit, 1 second cube is 1 second cube, so we cancel out the second cube, and 1 second square is 1 second square, so cancel out the second square. So this is the initial position when time is 1. Then for when time is 3 seconds, that is r of 3. Let me see the problem again. Yes, the final time is 3 seconds. Okay, and that is equal to 2.40 meter per second cube, 3 second cube, I hat, plus 3.10 meters per second square, 3 second square, j hat. Okay, so we have 2.40 meters per second cube. 3 second cube is 27 second cube, I hat, plus 3.10 meters per second square. 3 second square is 9 second square, j hat. Okay, so let us simplify this one. Okay, 2.40 multiplied by 27, that is 64.8 meters, as we cancel out the second cube here. Okay, I hat, then plus 3.10 multiplied by 9, that is 27.9 meters along j hat. We may cancel out the second square unit. Okay, so again, the r1 will determine the initial position along x and y, and the R3 will determine the position or the final position along x and y. So we may compute now the average velocity, wherein average velocity is equal to the change in x, which is 64.8 meters, minus 2.40. These are the values, 64.8 and 2.40. Then divided by the final time, which is 3 seconds, minus initial time 1 seconds. This is I hat, plus 27.9 meters minus 3.10 meters. Okay, these are the values, 27.9 and 3.10. And divided by 3 seconds minus 1 second, j hat. Okay, so the average velocity is equal to 64.8 minus 2.40 and divided by 2, that is 31.2 meters per second. We forgot the meters here. I hat, then plus 27.9 minus 3.10 and divided by 2, that is 12.4 meters per second, j hat. Okay. Okay, so this is again the average velocity from t is equal to 1 to t is equal to 3 seconds. And lastly, we're looking for the instantaneous velocity of the particle. Take note that the instantaneous velocity is again the derivative of the position with respect to time. Okay, wherein the r, or the position vector, is equal to this one. This one. Okay, so derivative of that is v of t is equal to the d over dt of 2.40 meter per second cube t cube I hat plus 3.10 meters per second square t square j hat. Okay, so derivative of that is again the derivative of 2.40 t cube is 7.20 meters per second cube t square I hat plus derivative of 3.10 meter per second square t square is 6.20 meters per second square t j hat. Okay, this is the instantaneous velocity equation, but we're looking for the instantaneous velocity when t is equal to 4 seconds. So we will just evaluate this by substituting t be equal to, again, be equal to 4 seconds. So, okay, so just substitute the time be equal to 4 seconds from this equation. So we have 7.20 meter per second cube 4 seconds square I plus 6.20 meter per second square 4 seconds j hat. So it will give you the velocity, or the instantaneous velocity when t is 4 seconds is 115.2 meters per second I hat plus 24.8 meters per second j hat. Okay. That's all. Thank you for watching.